So basically, what is MOSFET? MOSFET complete name is metal oxide silicon, or sometimes they called it as semiconductor also, because semiconductor is silicon only. FET means field effect transistor. Okay, so actually what the thing is, earlier there was a transistor in your syllabus, but now they have removed BJT. Basically transistor is divided into two parts. One is BJT and one is FET. So BJT was in your syllabus earlier 2 years before, but now it's in your syllabus FET is in your syllabus, and particularly FET is divided into two categories. One is JFET and one is MOSFET. So MOSFET is in your syllabus. I think JFET is not in your syllabus, right? Then now we'll study about the MOSFET. Before starting the MOSFET, I'm giving you a simple example. Like suppose we'll have a tap, and in the tap the water is coming outside like this. From here the water is incoming. So from where the water is coming inside the tap, that is known as source. Okay, and from here this tap, we are controlling the flow of water. We can control the flow of water by less, or if we want to increase the flow of water, then we'll increase it. So the thing which is used to control the flow of water, that is technically known as gate, right? And here the water is collecting, like it's a collecting. So this is technically known as drain, and this complete circuit will known as body. Understood? So basically we'll have four terminal: source from where water is coming, gate where from where we can control the water, drain where water is going outside, and the body. Okay, so now we'll flow the compare of this circuit with the MOSFET circuit. From where the current is coming, that is known as source. From where the current is controlling, we can control the current, that is gate. And where the current is leaving, that is drain. And that complete circuit is known as body. Understood this point? Now construction of MOSFET. As you know that they can ask you the construction of MOSFET. So I am taking the p-type body. Okay, it's a p-type body over here. P-type material. As you know, in the semiconductor we'll have p-type and n-type semiconductor, right? You have studied in the basics also. And in the p-type, now tell me, we can have the doping of what? N-type, right? So we'll have N positive type doping level over here. You know now what is doping? First of all, tell me. Adding impurities, correct. So basically, what's a kind of semiconductor? We'll have P type and N type. Combining it, it will form a diode. In this, we'll have P type body, but we add N type impurities in this body. Okay. Now here we'll give the supply. And how can we give the supply? By positive supply or by the negative supply, right? Like suppose this one is the source and this one is the drain. Okay, and in this we form a between a layer of simple metal oxide. Okay, why we provide layer of metal oxide? For the insulation purpose, so that current would not flow through this path. Got it? Insulation means we are providing insulating layers kind of something, so that current cannot move directly from drain to source or from source to drain. So that's why we put a insulating layer over here of metal oxide. Understood? Then we connect this one with the, tell me any doubt up to here? This P-type semiconductor forms the base of the MOSFET. The two types of base are highly doped with N positive region, that they are very heavily doped. From the heavily doped region, the terminal source and drain originates. Okay, then we form a oxide layer. We basically will use silicon dioxide for the insulation purpose, so that current would not transfer through source gate or source to drain, or from drain to, clear up to here? Hmm? Draw this diagram. Now, till now we haven't provided any supply. Okay, let's provide the supply over here. Source will be connected to the negative terminal and gate would be connected to the positive terminal, right? So now see what happens if I'll connect the gate with the positive terminal. It is connected with gate and source, so we can denote it by VGS, and it's a variable voltage. We can increase or decrease the voltage according to our convenience. Got it? Now see, if the positive terminals are there, here also the positive charges develop. Correct? Here also the positive charges develop. And what happens, as in the P-type base, as you know, maximum or the majority are the holes. Correct? But it's not like that every one having the holes. There are some of the minority carriers also. And what are the minority carriers in the P-type region? Tell me. Holes or electrons? I'm asking my electrons, right? So we'll have minority carriers, electrons. Now there is a positive charge develop over here. Now tell me, it will attract towards him electrons or holes? Tell me. Electrons. So whatever the minority carriers present in the P-type substrate will attract the electrons here. Yes or no? Clear? Right? As I know, there are not so many. Now one thing, if I increase the value for the VGS, if I increase the VGS, then minority carriers towards the moving towards this will be increase or decrease? Electrons moving towards this will increase or decrease? Can you tell me? Increase. Electrons will increase, right? Okay, if more I increase the VGS up to the maximum value, then maximum of the electrons will collect here and forms a region, right? Now see, here also we'll have N positive, means negative charges, electrons are there. In this region also we'll have N positive, means electrons in there. So as you know, if like we'll have N region over here, N region over here, N region over here. So will this wall remain there, or it will vanish by its own? Because there is always the wall between P and N, between the different carriers. There you never see the wall between the same carriers, right? Yes or no? So more and more electrons will be there. So automatically here also n thing is there, here also electrons are there, here also an electrons are there. Then automatically this wall will vanish towards this side. What we called it technically, this we called it as a N-type channel. Why we called it as N-type channel? Because more and more electrons are flowing through. It's a channel, it's a path. Okay. Now one more thing. If I'll increase the value of VGS, then current is increasing or not, or decreasing? If I increase VGS, then electrons increases, movement of electrons increases, and this path will become more and more deeper, right? Then in that case, more and more current will flow. Any doubt up to here? Now the next thing, we have to connect source with the drain also. Now I'm connecting source with the drain. Again, source is connected with the negative terminal and drain is connected with the positive terminal. Now see one thing, if I decrease the value of VGS, suppose, now what happens? Then less electrons will be attracted, correct? If less electrons will be attracted, then the path will be less, right? There is a like very narrow path, and if there is a very narrow path, then there will be the flow of electrons in a very less manner. So in this case, electrons is flowing from drain to source. ठीक है, मैंने VGS को कम करा, ये पाथ कम हो गया, पाथ कम हो गया, देन इन दैट केस जो इलेक्ट्रॉन्स जा रहे थे ड्रेन टू सोर्स से वो भी कम हो गए. तो बेसिकली अगर मैं VGS को कम कर रही हूँ तो ड्रेन करंट भी क्या हो रही है, कम हो रही है, राइट? और अगर मैं VGS को बढ़ा रही हूँ, ये वाली वोल्टेज को बढ़ा रही हूँ, देन पाथ ज्यादा हो रहा है, पाथ ज्यादा हो रहा है, देन मोर एंड मोर इलेक्ट्रॉन्स आर देयर, ज्यादा से ज्यादा इलेक्ट्रॉन्स फ्लो होंगे तो करंट भी ज्यादा फ्लो होगा, तो उस केस में ड्रेन करंट इंक्रीज हो रहा है. तो बेसिकली हम क्या कर रहे हैं, VGS को हम कंट्रोल कर रहे हैं और उससे तुम्हारी मूवमेंट ड्रेन टू सोर्स की कंट्रोल हो रही है. इफ वी कैन इंक्रीज, हम किसकी वोल्टेज को चेंज कर रहे हैं, गेट से हम कंट्रोल कर रहे हैं ना. मैं गेट को कम कर रही हूँ तो ड्रेन में पानी कम आएगा, राइट? इफ आई डिक्रीज द volume of the gate, then current decreases in the drain. But if I increase the voltage in the gate, then current in the drain increase, right or not? So basically we are controlling the gate, but from the gate we are getting controlled output in the drain. Graph based that, graph कैसा है? Graph is important whenever they'll ask you the question for the MOSFET, the theory question. Always have to draw the graph. Okay, this one is ohmic region. Now mark, I'll tell you what they are saying. VGS is here, GS is negative, here is positive, here the current ID, here is age VGS is positive. I'm showing the graph between the VDS and the drain current. Okay, so if VGS is negative 2.0, this is 1, this is 0, and VGS is suppose plus 1 and plus 2 volt. So see, basically there are three kind of region. This one is cutoff region. Back to this case, then I'll tell you. Like suppose we switch off the gate. Gate was completely closed. Okay, gate is completely closed. Then in that case, will the water will come out in the drain? Yes or no? I'm repeating. If the gate is completely closed, water will come out here in the drain? No. That is the cutoff region. In this case, we don't provide any gate. Next thing, if I open the gate normal way, now the normal water will come out towards the drain. Yes or no? Hmm? Yes. So if the normal thing is happening, that will be the active region. Now the last case, if I मैं ओपन करे जा रही हूँ करे जा रही हूँ करे जा रही हूँ करे जा रही हूँ, बहुत एक लिमिट से बाहर मैंने ओपन कर दिया, तो क्या एक लिमिट से बाहर पानी का फ्लो इंक्रीज होगा? बोलो, नहीं होगा ना? दैट इज सैचुरेशन रीजन. ओके, तो अगर गेट बंद है, क्या आई एम रिपीट, if gate is closed, no water is coming in towards the drain, so that is the cutoff region. Okay, cutoff means complete off. If the I open the gate in a normal way, then the water is coming out towards the region. It's a normal region. And saturation region is if I give more input, like I am opening the gate continuously, मैं open करे जा रही हूँ gate को, then drain में एक limit तक ही पानी आएगा, एक limit से ज़्यादा तो नहीं आएगा. That is saturation. Saturation region is like that कि I am giving input, I am teaching you for 2 hours, you are getting me the output, you are answering me the question. ठीक है? Now I told you for 4 hours, 5 hours, but I am giving my input. Will you be able to give me the answer up to 5 hours? No ना. तो मैं तो अपने इनपुट दे रही हूँ बट मुझे आउटपुट नहीं मिल रही. So that region is known as saturation. But you will say that ma'am, now our saturation region reaches, now we can't study more, right? Back to this. तो ये वाला जो रीजन होता है, ये वाला देखो saturation region है. इनपुट आ रही है, इनपुट मीन्स yes आ रही है, voltage is given, input we are giving, but we are not getting the output is constant. This one is the ohmic region. Ohmic, why they are saying, because if we are providing voltage, current is also increased, current increase. So this is basically the active region. Here we are not providing voltage, we are not getting the current, that is the cutoff region. तो बेसिकली ये 3 चीजों पे डिपेंड है, एस पे, VGS पे एंड करंट पे. ओके, like symbol of this one, symbol of, basically as I told you, MOSFET is divided into 2 parts. One is N channel, another one is P channel. The diagram which we have done, that was for the N channel, because they have formed N channel now. If I take it opposite, opposite means if I take the body of N channel, then it will form a, then I'll do the doping of P channel and then form the P channel. Okay, the symbol, write it down. It, this is source, this is gate is denoted by G, source is denoted by S, drain is denoted by D, arrow like circle. This is for the N channel. For the P channel, everything is same, but the arrow is on the opposite. Gate, source, okay. This is N channel, right? This is understood. And one more thing, they have divided the MOSFET into two different. First, write down this one, then I'll tell you. Okay. Again, the MOSFET is basically divided into two categories. One is the depletion type, and another one is the enhancement type. Okay. Depletion type and enhancement type, you don't need to go it further. Like तुम्हें यही पढ़ना है. ये whenever they'll ask you the MOSFET construction, तो ये सारी चीजें लिखनी है whatever I told you. ठीक है. बाकी written material I'll send it to you कि क्या लिखना है और क्या नहीं लिखना है. Now let's move towards. Now see, this is on MOSFET. Numerical are bit difficult for the MOSFET. I'll tell you first all the formulas which you MOSFET. ID is equal to 1 by 2 mu n cox by L is minus VTH का whole square. This is one of the formula. VDS is equal to minus ID RD. VDS is the drain to source voltage, VDD is the drain supply voltage, ID is the drain current, RD is the drain resistance. Okay. Another formula for that, if VGS is greater than VGS minus VTH, if its value is greater than VGS minus VTH, VGS is the gate to source voltage, VTH is the threshold voltage, then in that case MOSFET works in saturation region. Okay. Or we'll have different condition. If VDS is equal to S minus VTH, then in that case it will work as a active region. Okay. And if it's less then it will work as a cutoff region. I told you all the three regions, na, active, saturation and cutoff. So they will give you in the question. If they haven't mentioned anything, then we need to consider it's an active region. Okay. Now one another formula for VDS in terms of VGS is VGS minus H that I told. Okay, now based on these formulas we have to solve the question, right? Now first of all they ask you the drain current for the MOSFET. So I'm writing down the formula over here also. So ID is equal to 1 by 2 mu n cox by L GS minus VH ka square, right? Do we know mu n cox? Yes, it's given 100 microampere, means 100 into 10 raised to power minus 6. Now W by L is given. Yes, W by L is also given. Now VGS is given. VGS is not given. VGS is given. VGS is the gate to source voltage. As you know, this one is source. बताया था ना मैंने? ये क्या होता है? Source क्या होता है? Like in the symbol. This one नीचे वाला source, ये वाला gate and ये वाला drain, right? So this one is source, this one is gate, this one is drain. So now tell me, gate to source की voltage is how much? VGS is how much? 1 volt. Okay. Now VTH is the threshold voltage, that is also given 0.4. Do it and then tell me the answer. So after solving we'll get ID equal to microampere. In the next case we need to calculate R, drain resistance. So for that we need to do S is equal to minus ID RD, right? So whatever we get the value we have to use it here. 100 microampere means 200 into 10 raised to power minus 6. Okay. RD we need to calculate. VDD we don't know. VDS don't know. Let's calculate it. As I told you, VDS formula is what? VGS minus VTH, right? VGS is how much? 1 volt. VTH is how much? 0.4 volt. It would be 1 minus 0.4. How much we get it? 0.6. So we got VDS also 0.6. Now we need to calculate VDD, right? Now see the formulas. How can we get VDD? Can we get it by this formula? Drain to drain. No, it's okay. Let yeah, VDD is given 1 point. VDD is given. If I'll put it in this form, yes, is equal to, yeah. Then we can substitute the value over here. Yeah, VDD is given. We can substitute here. Then we'll get RD. Understood? Now see in this question, this is the another question. In this we need to calculate W by L value and the change in the drain voltage. Okay. Threshold voltage is given, that is VTH. So you remember we'll have one formula as I told you in the formula page, that is VDS is equal to VGS minus VTH, right? So now see the diagram. What is the VGS? VGS is the gate to source voltage, and how much they have given? That is 1 volt minus what is VTH? VTH is the threshold voltage, and how much they have given? Minus 0.4. So we got VDS as 0.6. Understood? Okay. Any doubt up to here? Sorry, 1 minus 0.54. Yeah. Now tell me, any doubt up to here? Now the next case, VDS we got it as 0.6. Now we need to calculate ID, right? So we'll have one formula, VD minus VDS is equal to ID into RD. Have this one also like a page, that is this one, VDD minus ID RD minus VDS, ये वाला formula. Okay, from this formula I get ID, correct? From this formula I can get the value for ID. VDD we know, DS we have calculated, RD they have given, from there we can get ID. RD दिया हुआ है, RD, VDS we have calculated, drain resistance I think they have taken first वाला. अच्छा, RD is, wait, RD is equal to 5 kilo ohm they have mentioned. एक बार करना calculate. VDS we got it as 0.6. ID we need to calculate. RD is 5 kilo means 5000 ohm. Change in voltage they have given, that is 1 millivolt. 1 into 10 raised to power minus 3. यहाँ से calculate करना what would be the value for ID. Now see, one of the thing will have LED. LED is like which we are using at our home. Another is photo diode. Okay. Can anyone tell what is the full form for the LED? You are using LED at your home now. The light emitting device. ठीक है, ये लाइट देता है and photodiode light लेता है. Okay, mainly photodiode is used in solar panels. In the solar panels it consumes light. So see, we'll draw a diode, both are diode. ये light लेता है, it consumes light, that's why arrow is like this, and it provides light, that's why arrow is on the outward side. This is basically the symbol. Next is a principle, like it emits light and it detects light. ठीक है. LED always worked on forward bias. ये हमेशा किस पे काम करता है? Forward bias पे. And photodiode always works on reverse bias. Okay. LED is made up of material of gallium arsenide, the combination of, or gallium arsenide phosphorus or gallium phosphorus. But photodiode is mainly made up of silicon or indium gallium arsenide. Okay. In this, leakage current does not exist. You know now what is leakage current? पता है? बोलो. Enough. Leakage current is the current which is flowing due to the minority carriers. Okay. Leakage current in the LED does not exist as you are using daily basis at your home. LED, like the light which you are using, in that no, there is no leakage current. But in photodiode, there is some amount of leakage current. Okay. And where we use LED again as a 7-segment display. 7-segment display के like you must have seen the digital watch. Digital watch में ऐसे होता है ना, like 1 2 होता है ना, like when it's 7 then it will be highlighted, right? When it's 6 then it will be highlighted like this, right? And in this photodiode, then photodiode is mainly used in rectifier solar panel. Got it? You know that LED आजकल बहुत ही different colors की आती है, right? Like red, yellow and all the things. If you'll have gallium and arsenide combination, then you will get infrared. If you'll have gallium arsenide phosphorus combination, then you have red color. If you'll have gallium arsenide phosphorus and nitrogen, then you will have yellow color. Okay. Similarly, ऐसे different combinations से we can get green, white and this. So now what are the advantages? Earlier तुम्हें याद होगा पहले एक बड़ी सी ट्यूबलाइट यूज होती थी, right? But आजकल they have replaced the bigger tubelight by LED. Can anyone tell me the reason कि क्यों हमने वो CFL या जो बड़ी बड़ी ट्यूबलाइट्स आती थी उनको हमने LED से replace करा है? One of the advantage is power saving, क्योंकि वो बहुत ही इलेक्ट्रिसिटी कंज्यूम करती थी और ये बहुत ही कम इलेक्ट्रिसिटी कंज्यूम करती. Plus point, cost is less, power consumed by is less, और प्लस ये छोटी होती है ना, मतलब CFL या LED वो तुमने देखा होगा ट्यूबलाइट बड़ी बड़ी होती थी, they are tiny, right? By using LED we can control electricity. तुमने देखा होगा आजकल we are getting the LED की हम उससे लाइट की इंटेंसिटी क्या कर सकते हैं, कम कर सकते हैं, ज्यादा कर सकते हैं और ज्यादा कर सकते हैं. तो ये बताओ पहले की जो ट्यूबलाइट्स आती थी, so we can control that amount of light, yes or no? No. So we can control, basically we can control the amount of light in LED. And how can we control? By controlling the amount of current. Current ज़्यादा देंगे तो ज़्यादा intensity आती है, current कम देंगे तो कम intensity, right? Understood? मैं I'm sending you the notes for LED and photodiode. मैं ज़्यादा deep में नहीं बता रही क्योंकि I doubt कि आएगा या नहीं आएगा. आएगा तो थोड़ा बहुत अब तुम्हें मैंने